بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will continue talking about counting. Let's begin with the types of selections or drawings. Let omega be a sample space. The selection from omega could be done in three different ways. It could be done successively with replacement, successively without replacement, and simultaneously. Let's see this example. An urn U contains 7 red balls and 5 blue balls. This is the urn. It contains red and blue balls. 3 balls are randomly selected from U. We need to choose 3 balls from this urn. The question is to give different examples about each of the given selections. Well, if the selection is done successively, give me an example about 3 balls that are selected successively. These 3 balls could be selected blue, blue, blue. Well, the first could be red, the second could be red, the third could be blue. The first could be blue, the second could be red, the third could be red. The first could be red, I put it aside, then I choose a blue ball, I put it aside. The first could be red, I replace it back to the urn. I choose another ball which is blue, I put it back to the urn, and then I choose a third ball which is also blue. I can choose a blue ball from the urn, I replace it back to the urn, I choose another ball which is red, I replace it back, I choose a third one which is blue. All of these selections are called successive selections. Now here we have successive with replacement and successive without replacement. With replacement means we choose the ball, then we put it back to the urn, and without replacement means we choose the ball and we put it aside. And what is the difference between these two terms? We're going to see it later. Now notice here, if I choose blue 1, blue 5, blue 2 is not the same as blue 2, blue 5, blue 1. So the first selection is not the same as the second selection. That's why here we say that the order is important. We're going also to see the meaning of order later. Well, what happens if I want to choose the 3 balls simultaneously? Simultaneously means at the same time. So within one selection, I choose 3 balls at the same time. These balls could be 3 blue balls. They could be 2 red and 1 blue, 1 red and 2 blue, or 3 red. Well, let's take specifically 3 blue balls. These balls could be blue 1, blue 2, blue 3, could be blue 3, blue 4, blue 1, could be blue 1, blue 5, blue 3. But here the order is not important. So if I choose blue 1, blue 2, blue 3, it's the same as blue 3, blue 2, blue 1. Let's begin with the first type of drawing, which is the successive drawing without replacement. Omega is a sample space. In a successive drawing without replacement, we select one item, we put it aside, then we select the second item, we put it aside, we select the third item, we put it aside, and so on. That's why it's called without replacement. So, in successive drawing without replacement, an item cannot be selected more than once, and the order is important. Let's see this activity. An urn U contains 7 red balls and 5 blue balls. 3 balls are selected randomly and successively without replacement from U. So we need to choose from here 3 balls successively without replacement. In other words, we choose one ball, we put it aside, we choose another one, we put it aside, and then we choose a third ball. The question is, how many different balls are there in the urn now? How many balls are in the urn? In fact, we have 12 balls. If you select one ball successively without replacement from you, how many different balls would still be in the urn? So in case we choose one ball from the urn and we put it aside, we're going to have 11 balls. And if you select another ball successively without replacement from U. How many different balls would be in the urn? In fact, we're going to have 10 balls, and if we select a third ball, we're going to have 9 balls. So whenever we select a ball, we look at its color and then we put it aside. What do you notice concerning the number of different balls? In this case, the number of balls was 12, then it became 11, 10, and 9. So we can see that the number of balls in the case of a successive drawing without replacement decreases by 1 each time we select one ball. So the total number of balls will be decreasing. Let's continue with activity 1B. An urn U contains 2 red balls, 2 black balls, and 1 green ball. 2 balls are selected randomly and successively without replacement from U. In how many different ways can these balls be selected? So in fact we have 5 balls, 2 red, 2 black, 1 green, and we need to choose 2 balls out of these 5 balls. How do we need to choose them? We're going to select them successively without replacement. Let's see how do we find these ways. The first ball could be R1, and if the first ball is R1, the second ball could be R2, B1, B2, or green. In this case, the first selection is R1, R2, then R1, B1, R1, B2, R1, G. Well, the first ball could be red 2, and if the first ball is red 2, the second ball could be red 1, or black 1, or black 2, or green. And the selections would be R2, R1, R2, B1, R2, B2, and R2, G. And the first ball could be a black one, and in this case we're going to have 4 different ways which are given here. And the first ball could be black 2, and this is the second ball. And finally the first ball could be green, so the second could be R1, R2, B1, or B2, and these would be the different selections. So in this case, the question is, in how many different ways can these balls be selected? You see, we have 20 different ways, and we don't have any repetition here. You see, each way is different from the second way. So we're going to have 20 different ways. Now notice here that 20 is 5 times 4. In fact, as you see, we have 5 groups, and each group contains 4 different ways. So the answer is 5 times 4. Now, how can we find a relation between 5 times 4 and the given of the question? Let's see the results from activities 1A and 1B. In a successive drawing without replacement of P items out of N items, so if we have N items and we need to select P items out of them successively without replacement, the total number of items, which is N, decreases by 1 each time we select one item. This is the first result, which is very important. And the number of possible different selections would be N multiplied by N minus 1 multiplied by N minus 2, blah blah blah, P times, and this is what we call the arrangement NP. Let's see this example. An urn V contains 10 balls. 4 balls are to be selected randomly and successively without replacement from V. In how many different ways can these balls be selected? So what's important in this question, we have 10 balls and we need to select 4 balls out of these 10. How do we need to select them? We select them successively without replacement. So according to this result here, we're going to see that the number of ways would be 10, which is the total number of balls, multiplied by 9, multiplied by 8, multiplied by 7, and this would be 40 different ways. Or we can use the arrangement, which is here. A, from 10 items, we need to choose 4 items, and this would be also 40 using the calculator. Let's take an application. In grade 12, we have 15 girls and 12 boys. So the total is 27 students. 3 students are to be selected randomly and successively without replacement from grade 12, and the question is to find the number of different ways of choosing these students. Try to do it alone. So in this case, we have a successive drawing without replacement. We have 27 students, then it decreases by 1 to become 26, then 25. Because we need to choose 3 students, so we multiply 3 numbers by one another to get this answer. Or we can use the arrangement, which is in this case A. From 27, we need to choose 3, and we get the same answer. Let's continue. An NU contains 4 red balls, 7 black balls, and 3 green balls. So it contains 14 balls. We need to choose 3 balls out of them, one after another without replacement. This means successively without replacement. So in fact, we have 14 balls and we need to select 3 balls out of them successively without replacement. The first part asks about the number of different ways of selecting these balls. So we're going to have 14 times 13 times 12, which is 21, 84 different ways. We are applying the result of activities 1A and 1B. Now we're going to go deeply in how many different ways can these balls be selected if they have the same color. Now we have here a certain condition that should be satisfied. The condition states that the selected balls should have the same color. Let's see how do we do it. The first could be red, the second red, the third red, or the first could be a black, the second is a black, and the third is a black, or the first could be green, the second could be green, and the third could be green. Remember, even though we are choosing from the 14 balls, here specifically we need the ball to be red, for example, to be black, to be green. So we have a certain condition. We use the same way of thinking, the same strategy to answer this question, but here we have to pay attention that the total will be different. So in the first case, the total of red balls is 4. It's not going to be 14 anymore. So to choose one red ball out of 4, this would be 4. Then we put it aside, we choose another one. We're going to have 3, then we have 2. And OR is going to be represented by this plus. Now black, we have 7 black, so it becomes 7, 6, 5. And this OR would be also represented by a plus. And then a green, we have a 3 green balls, so we get here 3 times 2 times 1. So we use the same previous way, which is the arrangement way. But here we have to pay attention to the total of each subset. So we're going to have 240 different ways. Let's apply more. In how many different ways can these balls be selected if exactly one red ball among the 3 selected balls is selected? So we're going to choose 3 balls, but we need exactly one red ball among them. So having one red ball only means that we're going to have 2 balls which are not red. So this is the way we write it by. So the first ball could be red, so the second one should be non-red, and the third one should be non-red. And this bar means none or not. Or we might have another way. The first ball should be non-red, so the second should be red, and the third should be non-red. Or we're going to have the first ball is non-red, the second ball is non-red, and the third ball is red. Now, how do we answer such a question? Let's begin. The first one is red, so we are choosing one ball out of 4. This is 4. The second one should be non-red, so we try to divide here the sample into 2 groups, the groups of red and the groups of non-red. In fact, we have 4 red and 10 non-red. So here we will have 10 and then we will have 9. Remember, it decreases by 1 because we are choosing the balls successively without replacement. Now OR, this is OR, which is a plus. the first ball could be non-red, so 10. The second one is red, which is 4, and the third is non-red, which is 9. And similarly for the third case. And this would be nothing but 360 plus 360 plus 360. And we all know the relation between addition and multiplication. So 360 plus 360 plus 360 is nothing but 3 times 360, which is 1080 different ways. And here, in fact, we could have found only one of these three cases and then multiplied it by 3. This is what will happen here. Remember, in order to get exactly one red ball among the 3 selected balls, so the first could be red, the second should be non-red, and the third should be non-red. And here we multiply by the order. Now the order of what? The order of such case. Remember here we have 3 different letters, and 2 letters are repeated twice. So here we have 4 multiplied by 10, which is the number of non-red, multiplied by 9, which is also the number of non-red, and we multiplied it by 3 factorial over 2 factorial. This is a 3-letter word, 3 factorial. 2 letters are repeated. This is 2 factorial. And we get 360 times 3, which is 1080. Now, in fact, I prefer the second way, which is here, because sometimes we're going to have 6 or 7 or 10 or I don't know 100 different cases, so we cannot always repeat them. That's why it's better to take only one case and then multiply by the order. And this is what we meant by the order is important in a successive drawing. Let's continue with this application. A school has 120 boys and 80 girls. 4 students are to be selected randomly and successively without replacement. In how many different ways can these students be selected? Try to do it alone, but remember here that we have 200 students and we need to choose 4 out of them randomly, successively without replacement. Try to do it alone. So here we have 200, 199, 198, 197, which is this very huge number, or we could have used the arrangement. Now, in how many different ways can these students be selected if they have the same gender? Try also to do it alone. Well, in this case, we're going to have boy, 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 or girl, 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 girl. Now the selection will not be done from the 200 students, but we're going to take the first selection from 120 because they should be selected from the boys, and in the second case we're going to select it from 80. So we're going to have 120 times 119, 118, 117, and this all is translated into a plus, and then girls 80, 79, 78, 77, and this would be the number of different ways. Now one might ask, why don't we use the order here? Remember, the order of such a word, which is B, 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 is going to be 4 factorial over 4 factorial, and 4 factorial over 4 factorial is 1, and the product by 1 doesn't change the result. So whenever we have a successive drawing without replacement, the order is going to be very important, but specifically when we have the same letters like this case or this one, we're going to see that we will ignore the order. Now the third case, in how many different ways can these students be selected if exactly 2 boys among the 4 selected students are selected? So we need exactly 2 boys. If we have exactly 2 boys, this means that we have also exactly 2 girls. Try to do it alone. Well, we're going to have boy, boy. These are 2 boys. So girl, girl. We're going to have 2 boys and 2 girls, and we multiply by the order instead of stating all the different cases. So a boy is selected in 120 ways, then another boy 119, a girl 80, another girl is 79, times the order of such a word. It's a word that contains 4 letters, so we have 4 factorial. B is repeated twice, we get 2 factorial, and the G is repeated twice, we get also 2 factorial. And this would be the answer. Now let's see the last case. In how many different ways can these students be selected if at least 3 boys among the 4 selected students are selected? So we need here at least 3 boys. So we need 3 boys and 1 girl or 4 boys. This is the meaning of at least 3. Try also to do it alone. Remember we have 2 cases. Well, at least 3 boys, so we're going to have boy, 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 girl times order, or 4 boys, which is B, 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 B. Again and again, we're not putting here the order because the order of such a word is 1. Now, to choose a boy, we have 120 ways, then 119, 118. To choose a girl, we have 80 different ways. So we multiply by the order of such a word, which is 4 factorial over 3 factorial, or is translated into a plus. And here 4 boys, so this is what we have, and this would be the final answer.